Hi, I'm Kashish, and today I'm going to discuss homework 9 problem 1 for EL6303. So our problem is that we've been given a stochastic process with the expected value of the process W of t equal to 0, and our W of t1 t2 is equal to alpha minimum t1 t2, and we've been given Y of t is equal to W of t minus 1 for t greater than or equal to 0. So we need to keep in mind that the minimum value for t will be 1 and below that it will be 0, and we have to find the expected value of y of t and r y of t1 t2, and then deduce if y of t is a Whitehead stationary function or not. So starting with the expected value, now this could be done in a much easier manner, such that we know that W of t is a stochastic process. A stochastic process is basically a random process, and since y of t is basically made up of a random process, we can say that the expected value is 0 because expected value of a random process is always 0. Or you could simply do it this way: E of y of t is equal to E of W of t minus W of t minus 1. Expected value is a linear function, so you can just open the brackets and apply it, and then this will be 0, and since this is 0, this will also be 0, so 0 minus 0, 0. The second part is that we have to find Ry of t1 t2. So Ry t1 t2 is expected value of y of t1 or y1 of t1 and y2 of t2, and we know y of t is basically W of t minus W of t minus 1, so we just change the value of t to t1 in this case and value of t to t2 in this case. So W of t1 minus W of t1 minus 1 into W of t2 minus W of t2 minus 1. Open up the brackets. Again, expected value can be linearly used where there are additions and subtractions, but we must remember that it cannot be used when there's a multiplication unless it's independent. So so basically open up the brackets from here to here, then put expected values of these functions separately. And so this is basically expected value of one random function into another random function, which is the r of t1 t2. So once you've done this and you come down to this, so this will basically be rw of t1 t2, rw of t1 t2 minus 1, rw of t1 minus 1 t2, rw of t1 minus 1, and t2 minus 1. So like I said, we have to keep in mind that the minimum value for t is going to be 1. So the minimum value for t1 or t2 should also be 1. And we consider that t1 is greater than t2. So once you open up the brackets in such a way that you know that Rw of t1 t2 is alpha minimum t1 t2, so you're going to get alpha min t1 t2 minus alpha min t1 comma t2 minus 1 minus alpha min t1 minus 1 comma t2 and alpha min t1 minus 1 comma t2 minus 1. So we know we are assuming that t1 is greater than t2, so of course alpha min t1 comma t2 will be alpha t2, and then t1 comma t2 minus 1. So let the value of t1 be say 4 and value of t2 be 3. So 4 comma 3 minus 1 2 will basically give you this is the smaller value, and then so you're gonna get alpha of t2 minus 1. Then you go down to this and again consider t to be 4 and say t2 to be 3, so you're gonna get 3 comma 3, which is basically taking the same value. So now you keep a difference of more than 1 between the two values and say this is 5 and this is 2. So 5 minus 1 and 2 is going to give you 4 comma 2, and you're basically getting this. So alpha of t2. And amongst these two, since it's direct, t1 is greater than t2, so therefore alpha of t2 minus 1. So you can take alpha common and you'll be left with this inside, and you're going to get all of this is 0, so alpha into 0 is 0 and Ry of t1 t2 is 0. The next thing is that you have to find if f of y is, y of t is Whitehead stationary or not. So of course one condition is satisfied, that expected value of y of t is a constant, but the other condition is that expected value should be a function of t1 minus t2, or t2 minus t1. Since it's not a function of tau, which we famously call tau, we can say y of t is not Whitson stationary. Thank you.